Hello, I am Kiran Kumar from Nature of Physics. Today topic is kinetic theory of gases, the motion of a gas molecules in a cubical container in which average velocity, most probable velocity and also RMS velocity of a gas molecules with respect to pressure, temperature and volume and kinetic energy of the gas molecules in a cubical container. Step by step clear explanation and neat diagram and derivation I'm going to explain. Please do like and subscribe our channel Nature of Physics. See student, first I am considering there is a 1 mole of an ideal gas in a cubical vessel. This is a cubical vessel in which 1 mole of ideal gas considering, and side of the cube is taken L and area of the cube is L square, volume of the cube is L cube because of it is in cube shape. Okay, and N is equal 1 written, PV is equal to nRT is a ideal gas equation, and V is the velocity of the each molecules, so that V square is equal to Vx square plus Vy square plus Vz square because of the motion is possible along the x-axis and also y-axis and also z-axis, that is diagonal square is equal side square plus side square plus side square, three-dimensionally I gave you. So small m is the mass of the gas molecule and velocity of the molecule from the p position to q position along the x-axis. Due to the velocity, the particle means the gas molecule get the momentum, that is taken forward momentum is mv from p phase to q phase, and the gas molecule get reflected back from q phase to p phase, so that's final momentum is minus mv, minus represent opposite in direction. Okay, so change in momentum I'm going to write change in momentum nothing but final momentum minus initial momentum delta p along the x-axis, which is equal to pf minus pi. So final momentum minus mvx and initial momentum is mvx, between them minus is there, so that delta p value which is equal to minus 2 mvx, I got change in momentum along the x-axis. Now I am writing only magnitude equation, so mod delta px is equal to 2 mvx. Okay, negative sign no need to consider, and then continuation total time taken from the p phase to q phase after collision from q phase to p phase, so that time taken I'm going to find. Before that, velocity vx which is equal to forward length is L and backward length also L divided by T, writing from this equation T which is equal to, we can write 2L divided by Vx student. Okay, so that delta T writing that is equal to 2L divided by Vx is written as the time interval from the p phase to q phase and q phase to p phase after collision with the q wall. Okay, and also same thing along the x-axis only I'm going to find the force on the molecules, that is Fx which is equal to delta Px divided by delta T, see clearly given. Okay, and in this Fx which is equal to delta Px, this is from Newton's second law, so Fx is equal to delta Px by delta T. Okay, and Fx which is equal to delta Px I got, that is 2 mvx divided by delta T value is 2L divided by Vx. So finally we are getting there Fx which is equal to 2 to get cancel, so m into Vx is Vx square divided by L. Okay, so force I got student. After that I am going to find the pressure along the same x-axis. So pressure on a molecule along the x-axis finding, so that pressure equation Px which is equal to Fx divided by A. Okay, and continuation step Px which is equal to Fx value is mvx square divided by L. Okay, and whole divided by area value is writing L square, area is equal to L square and I'm getting there px which is equal to mvx square divided by L into L square. Okay, see there, px which is equal to mvx square divided by L cube, so that L cube which is equal to volume, so that px which is equal to mvx square divided by v is the volume, student. This represents the volume of the container, clearly given in the diagram and also explanation. See there, so I got the pressure along the x-axis. Okay, so derivation is clearly step by step given. Okay, you can clearly understand there. Okay, this is a by b, this is c by d, a by b into d by c, so that I am getting L into L square, that is L cube is volume, clearly written. And also similar step I can write py, no need to do again derivation, similarly writing along the y-axis pressure which is equal to mvy square divided by v, and also pz which is equal to mvz square divided by v is the volume. Okay, student, and then continuation, next step we will discuss about the average pressure along the x-axis, y-axis and also z-axis. See there, I'm writing p average which is equal to px plus py plus pz divided by 3. Okay, student, and then values are replacing now. P average is simply writing now P which is equal to Px is m divided by V, x square plus y square plus z square, writing in this m divided by V is common, so that sigma Vx square plus Vy square plus Vz square I got, and whole divided by 3 is there, whole divided by 3. See student, m divided by 3v common, sigma Vx square plus Vy square plus Vz square, and here V square is equal to written Vx square plus Vy square plus Vz square. Now this is equation number. Next step I'm going to write like this, equation 1 in equation number 2, so that we will get here P which is equal to m divided by 3v into sigma Vx square plus Vy square plus Vz square which is equal to V square, and continuation step in this n, capital N is multiplying and dividing, student. Okay, so capital N is the Avogadro number, so Avogadro number, that value is 6.023 into 10 to the power of 23 per mole. Okay, so n is multiplying and dividing for this equation. Pressure we got. Okay, so pressure P which is equal to m 1 divided by 3 m divided by v, n multiplied capital N sigma V square divided by n. Okay, and in this step here VRMS I am writing, so VRMS which is equal to sigma V square, this is velocity, V square, this is volume. Try to understand the difference between them. Okay, velocity, okay, represented like this, small v letter, and capital V represent the volume, divided by n represent, what is that, student? RMS velocity, root mean square velocity. One more step I wanted to write here, that is C VRMS, another equation. So VRMS which is equal to root over V1 square plus V2 square plus V3 square up to so on Vn square whole divided by n writing. Okay, student, and then the values is replacing according to this. So pressure equation, I'm getting P which is equal to 1 divided by 3 small m into capital N divided by volume V into V square RMS. Just to value replace the sigma V square divided by N is equal VRMS. This is the another equation for this root mean square velocity, which is equal to root over V1 square plus V2 square plus V3 square up to so on Vn square divided by N. N represent the number of molecules of the gas. Okay, and in this is I'm considering equation number 1, that is the basic equation. Roman number writing, student. Up to here I gave you equation 1 2 different equations. So using this equation I'm going to write the different equations. Okay, so everyone look at this clearly, step by step I'm going to explain for the different equations of the RMS velocities. See student. Okay, now continuation here VRMS square, and one more step I want you to write, that is small m into capital N, which is give the capital M. Capital M is the total, okay, mass of gas molecules, total mass of the all gas molecule, total mass of all gas molecules. Okay student, and replacing that we will get P which is equal to 1 by 3, that is capital M divided by V into V square RMS. Okay, and one thing we have to notice there, mv square is there, so we can write the kinetic energy. That's why 2 multiplying and dividing student there. So P which is equal to 2 divided by 3 1 by V into 1 by 2 capital M V square RMS. See there, we are getting kinetic energy by multiplying 2 and dividing 2. Okay, and then continuation equation, so kinetic energy replacing, so and also same time writing denominator value 3 and V from RHS side to LHS side, that is 3 PV, which is equal to whole divided by 2 also we can write, which is equal to, so that is kinetic energy. Only RHS side I wrote kinetic energy. Kinetic energy is of mv square RMS. Okay, and next step, that is equal to kinetic energy which is equal to 3 by 2 into PV, but PV is equal to 1 RT, ideal gas equation. So the value is replacing now, we will get there, that is kinetic energy which is equal to 3 by 2 into RT. This I can write as equation number 2 student. Okay, Roman number. And also kinetic energy is directly proportional to the temperature. So whenever temperature of the gas molecules increases, then kinetic energy of the gas molecules also increases. This is the relation between the kinetic energy and temperature of the gas molecules. See there student, step by step clearly I gave you about the kinetic theory of gases, of motion of a gas molecules in a cubical container, in which we got the pressure equation and also kinetic energy equation. So that pressure P which is equal to 1 by 3 capital M divided by V into V square RMS. See student, using this equation I'm going to find the remaining velocity equations step by step. Okay, and 1 second please. See here, using this equation, first one is cross multiplication, that is 3 PV divided by capital M, which is equal to V square RMS. See there clearly. Okay, so 3 PV divided by M which is equal to V square RMS. Okay, and first equation, that is equal to V RMS, which is equal to root over 3 PV divided by M. Now this first equation I'm writing, student, see there. Okay, and continuation, second one is this, but PV is equal to 1 RT. Actually nRT, N is returning as 1 because of 1 mole of gas considered already. Okay, and replacing in the above equation, that is V RMS, which is equal to root over 3 RT divided by M. This I can write as equation number 2. See, student. And also next introducing, that is we can write, K is the Boltzmann constant. So capital R is equal to N into K, student. N Avogadro number already I gave you information, but K is taken as Boltzmann constant. Boltzmann constant. Okay, so that K value is 1.38 into 10 to the power of minus 23 joule divided by Kelvin. Okay, student, and continuation step I am going to write there, and another one also. So here capital M, which is equal to small m into N. Both the values are replacing in the above equation. So the resultant equation is V RMS, which is equal to root over 3 into R value is NK into T divided by denominator is small m into N. So that N is get cancelled, so that V RMS, which is equal to root over 3 KT divided by small m, I am getting. So this I can write as equation number 3. Clear information about the RMS velocity with mathematical proof. 3 equations I got, student. And also next we can modify these equations step by step, student. So the modification of equations by using the ideal gas equation and relations. Now P, which is equal to PV is equal to 1 RT. Okay na? And next step I can write there. So small n is equal to small m divided by capital M. So there one thing you have to notice, molecular weight N is the number of molecules, which is equal to weight divided by molecular weight of the gas. So that N is equal 1 already taken. So in this derivation I am replacing there 1 is equal small m divided by capital M. Okay, so finally I am going to write small m is equal to capital M and PV is equal to RT, student. So that the value is replacing from the equation 3. Okay, otherwise directly write in the equation 1, just replacing m is equal, what is that, small m, student. So I wanted to consider directly from this equation. So that from equation number 1, so V RMS, which is equal to root over 3 PV divided by, okay, instead of capital M I am writing as small m, student, because of clear information is given there. Again I don't want to write. Now this is I can write as equation number 4, student. See there, PV divided by small m. Okay, and also here also we can replace for the same condition. VRMS is equal to, what is that, student, for 1 mole of gas. Here also we can replace small m, capital M is replaced by small m. So VRMS, which is equal to root over 3RT divided by small m. This equation I can write equation number 5. But one thing remember, in the both equations, so n is equal to small m divided by capital M, but n is equal to 1. Then I wrote small m is equal to capital M. Please try to understand this relation. Particular condition only we can take this equation 4 and 5. Regularly we can use equation 1, 2 and also 3. So there is a problem related to this. Okay, so that after that continuation derivation I will solve this problem. Wait a second. And also from equation number 4 we can replace density rho, which is equal to mass divided by volume. Okay, so that VRMS, which is equal to root over 3p divided by m divided by v, student, root over from here. So the value is replacing, so that we are getting VRMS, which is equal to root over 3p divided by rho. 3p divided by rho. Now I can write this is equation number 6. See the difference from the equation 1, 2, 3 and also 3, 4, 5, 6. Okay, and next one, numericals. And before going to numericals, I wanted to write the formulas of the most probable speed. Okay, most probable speed. Most probable speed VMP, which is equal to root over 2 divided by 3 into VRMS. Root means square speed. Okay, so that most probable speed is root over 2 by 3 times the RMS velocity. Okay, now I can write this is equation number 7. Okay, already I gave you VRMS value there. VRMS, which is equal to, we can write root over V1 square plus V2 square plus V3 square plus up to so on Vn square divided by n, student. This is the basic formula. And continuation, next step I'm going to write for you, that is about the average speed. Okay, for average speed, V average, which is equal to root over 8RT divided by pi into capital M. Capital M is molecular weight. This is, I can write as equation number 8. So these are the very useful formulas to solve the many questions from the kinetic theory of gases. Clear information, detailed step by step I gave you, student. And 2 problems, simple problems are getting from the equation 1, 2, 3, and little bit difficult problems we are getting from the equation 4, 5, 6, 7. So 7, 8 also easy, student. Okay, so especially equation number 4 and equation number 6. So equation 4 related this problem, equation 6 related this problem. I'm going to explain. Wait a second, continuation. See there, student. Now continuation in this question. So at a pressure P is equal 24 into 10 to the power of 5 dyne per centimeter square. The volume of a gas, that is hydrogen gas, is 10 liters given, and mass is equal to 20 grams given. RMS velocity is asking. See there, RMS velocity VRMS, which is equal, I'm replacing that value VRMS, which is equal to root over 3 into pressure is given 24 into 10 to the power of 5. 1 dyne is 10 to the power of minus 5 Newton divided by 1 centimeter square is 10 to the power of minus 4 meter square. Okay, into volume is given, volume is equal to 10 liters given, that is 10 into 10 to the power of minus 3 meter cube. Mass also given in grams, that is 10 to the power of minus 3 kg. Derivation 10 to the power of plus 5 minus 5 is get cancelled, and see that, and 10 to the power of minus 3 also get cancelled, so that we will get V RMS, which is equal to root over 3 into 24 into 10 divided by 20 I got. Okay na? So then continuation 0 0 also get cancelled, and from denominator to numerator this is 10 to the power of minus 4. Okay student, so VRMS, which is equal to, so this minus 4 become plus 4 from denominator to numerator. Okay now student, and this is we can write 12 student. Okay, and that is 36 root over 36, okay, into 10 to the power of plus 2 writing. This is square root of cancel for the 10 to the power of plus 4. So I am getting finally there VRMS, which is equal to 6 6 36, 6 into that is 10 to the power of 2 is 100. So final answer is VRMS, which is equal to 600 meter per second. Clear information with the derivation we did student. See that. So what is the velocity? That is RMS velocity of monoatomic gas having the pressure is equal 1 kilopascal. 1 kilo nothing but 10 to the power of 3 pascal, and density also given rho, which is equal to 4.8 gram per kg. I did mistake there, kg per meter cube, clearly written. Okay, so that density related formula just now completed, that is VRMS, which is equal to root over 3p divided by rho. Values are replacing now. See, VRMS, which is equal to root over 3 into pressure is 10 to the power of 3 divided by 48. So I am doing there 10 multiplying and 10 dividing, so that VRMS, which is equal to root over, this is 3 into 10 to the power of 4 divided by, this value is 4.8. 4.8 become, what is that student? 48. Okay na? So this is equal to 1 and this is equal to 6. Okay, 3 ones 3, 16 times 48. Okay, so VRMS, which is equal to, here rewriting the value, that is 1 by 16 into 10 square whole square. Square root of get cancel, so that we are getting there 100 divided by 4. So VRMS, which is equal to 25 meter per second, is the answer for the given question. Okay, calculation you can do in your own way. Please do like and subscribe our channel. Thank you students.